In this session, we are talking about logarithmic function. But before talking about that and how to graph it, let's have a quick review of the definition of logarithmic function. A logarithmic function is defined as log base with a base and an exponent and a number. This is inverse of an exponential function where we have a base, an exponent, and a number. Now, in both, we have y, which is the exponent, then we have b, which is base. Y is the exponent that we raise base to it in order to get a number. So the number is x. That is our outcome. Now, this is how we write and define a logarithmic function, which is inverse of an exponential function. Let's compare a logarithmic function and an exponential function. So a logarithmic form and an exponential form. In logarithmic form, for instance, we have log base 2 of 8. Log base 2 of 8 is in fact asking us to what power must we raise a number, which is 2 here, in order to get 8. So the answer is 3. If we wanted to write the exponential form of that, that would be 2 raised to the 3 equals to what number, which is 8. Or let's say we have log base 3 of 1 over 9. Again, we are asking to what power we have to raise this 3 in order to get 1 over 9. The answer is -2. And if the exponential form, we can write it as 3 raised to -2, which is equal to 1 over 9. Or log 2 to what power give us 16, which is 4. And the exponential form would be 2 raised to 4 give us what? That is going to be 16. You can go the reverse form too. You can write it as, for instance, 6 to raise to second power, or 6 squared, equals to what? 36. And if we are to write the log of that, we can write it as log base 6 raised to what power give us 36. So log 6 of 36 equals to what number, which is going to be 2. Or let me write another one. 5 raised to third equals to 125, right? So if you wanted to write the log for that, we can write it as log base 5 of 125 equals to what number, which is going to be 3. It means 5 has to be raised to 3 in order to get 125. So this is the form that we write exponential form or logarithmic form. Now let's see how we can graph it. Let's say we are asked to graph f of x equals to log 2 of x. the first thing we do is to write it in exponential form. So we write it as 2 to the y equals to x, right? 2 is our base and y would be our exponent. If you recall, we graphed an exponential function before where y was equal to 2 to the x. Let's graph this exponential function first and then we do our log. Let's draw a chart as usual. So we'll have some x values, some y values, and pairs to graph, right? So if we choose 0 as x, then 2 to the 0 would be 1. So our pair is 0 and 1. If we choose 1, and then 2 to the first power is going to be 2. So our pair is 1 and 2. If we choose 2 as x, then 2 to the second power would be 4. So our pairs are 2 and 4. Then we have, let's choose 3, and then 2 to the third power is going to be 8, and 3 and 8 is our next pair. Let's go other direction. Let's choose -1, and then 2 to the -1 will be half. So our pair is -1 and half. So let's choose a -2. 2 to the -2 is the same as a 1/4. So our pair is -2 and 1/4, right? Let's graph this one. So this is our x axis and this is our y axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me complete my x and y axis. 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now if we have x is 0, then y is 1. So this is our first point. If x is 1, then y is 2. So x is 1, y is 2. If x is 2, y is 4. So it's going to be here. If x is 3, y is 8. So 1, 2, 3, 4, 5, 6, 7, 8 is going to be here. If x is -1, y is half. So x is -1, y is half, somewhere along here. If x is -2, y is 1/4. So it's going to be somewhere here. And we can connect these dots and have our line is going to be something like this one. And if we continue, it's going to be like this. So this is an exponential function, is where y equals to 2 to the x. It shows the growth, so the model is exponential growth. Now we know that a log is the inverse function of an exponential function, right? So now we are ready to pick some values instead of some x values here to solve for this log. So we clear this section. Now we can choose some y values and get our graph going. So this is x and y and our pairs. Now we are ready to pick some y values and find the corresponding value of x. So if we pick 1 as y, then 2 to the first power give us a value of 2. So we'll have a 2 and 1 as pair. If we raise 2 to the second power, then we'll have a value of 4 for x. So 4 and 2 is our pair. If we choose 3, then 2 to the third power is equal to 8, and then we'll have 8 and 3 as our pair. Let's go to other direction. Let's choose 0 as a y, then we'll have 1. 2 to the 0 equals to 1, and then our pair is 1 and 0. What about minus 1? 2 to the minus 1 is same as half, then we'll have half and minus 1 as our pair. And let's pick one more, and that is minus 2. Then we'll have 1/4, and that is going to be, our pair is going to be 1/4 and minus 2. Now let's graph this one. Let me choose another color. If x is 2, y is 1. So x is 2, y is 1. It's going to be here. If x is 4, y is 2. So 1, 2, and this is 4 is going to be here. If x is 8, y is 3. 1, 2, 3, 4, 5, 6, 7, 8, and this is 3. If x is 1, y is 0. If x is half, y is minus 1. It's going to be here. If x is 1/4, and then y is minus 2. So we can draw this line. It's hard to get this right, but this is continue along the y-axis. So this is our log base 2 of x. The first thing you observe is these two graphs are the mirror image of each other. If you draw a line across the graph, you can see that these two lines are symmetric. So if we call this line y equal to x, you can see these two graphs are reflection of each other. The second thing you notice is the domain of the x. X is larger than 0. Basically, it means that it never reaches 0. If you put more negative number, it gets smaller and smaller, but it never gets 0. And the third characteristic of these two graphs, are the asymptote. The asymptote is this line, you can see it shows the boundaries of this line that never reaches the 0. So for y, it has an asymptote of 0, and for x, it has an asymptote of 0. Now let's graph another log. Let's say we are asked to graph y equals to log base 3 of x plus 2. We start with x and then we add 2 to the function. But before that, the easy way to calculate the log is to write it in exponential form. So we write it as 3 to the y equals 2x. So we try to find this one, x, by writing an exponential function, and then we find the log. So let's say 3 to the 0 equals to 1. So if we raise 3 to the 0, we get 1. If we raise 3 to 1, we get the x value of 3. If we raise 3 to 2, we get the x value of 9. Let's go the other direction. If we raise 3 to minus 1, we get x value of 1/3. If we raise 3 to minus 2, we get 1/9. Or if we raise it to minus 3, we get 1/27, right? Now we can write it in logarithmic form. Log base 3 of 1 equals to 0. This is the reverse of the exponential function. So log base 3 of 3 equals to 1. Log base 3 of 9 equals to 2. Log base 3 of 1/3 equals to minus 1. Log base 3 of 1/9 equals to minus 2. Log base 3 of 1/27 equals to minus 3. Now we can add two to the function and find our pairs. So we write as log base 3 of 1 plus 2 equals to 2, because log base 3 of 1 is 0. 0 plus 2 is 2. That equals to 2. Let's call it this one x and y, and this is our pairs. So when y is 0, x is 2, so our pair is 2 and 0. So log base 3 of 3 plus 2, 1 plus 2 equals to 3. So when y is 1, x is 3. So 3 and y. Then log base 3 of 9 plus 2. Then y is 2. Exponent is 2. 2 plus 2 is 4. So our pair is 4 and 2. Next is log base 3 of 1/3 plus 2. 3 to the minus 1 power is 1/3. So minus 1 plus 2 is 1. So when y is minus 1, x is 1. So 1 and 1 minus 1. Log base 3 of 1/9 plus 2, that equals to 0. When y is minus 2, x is 0. So 0 and minus 2. Log base 3 of 1/27 plus 2. When y is minus 3, x is minus 1. So minus 1 and minus 3. Now we can graph it. Let me clear this section, and then we can graph it. This is our x-axis, and this is our y-axis. Let me complete my number line. Now we can graph it. When x is 2, y is 0, so is here. When x is 3, y is 1, so next one is here. When x is 4, y is 2. When x is 1, y is minus 1. So when x is 0, y is minus 2. When x is minus 1, y is minus 3. So the graph would look like something similar to this one. So minus 3, it passed minus 3 and comes down. So it has an asymptote line along with y-axis. So this is the graph for log base 3 of x plus 2. Now let's do some practice at home. Let's graph the following logarithmic function y equals to log base 2 of x minus 1, y equals to log base 3 of x plus 4, log base 2 of x x plus 4, log base 5 of x minus 5. So with that, we are at the end of our session on logarithmic function. See you next time.